In the last video, Miss Olson talked about what makes something a function, and you did a little investigation on that in class, and hopefully by now you have a good idea of what makes something a function and what doesn't. And what we're going to talk about now is we're going to talk about a different way to write equations. So what you've seen in the past is you've seen a lot of equations written in y equals mx plus b form. Like for example, y equals 2x plus 1. You've seen equations probably written in a lot of different ways. You've seen them written maybe with some like letters. Something like that. But we're going to talk about a different way to just use notation differently. And so this is called function notation. We're going to talk about how it's useful and why we use function notation. Okay, so here's what it looks like. It's a specific notation. That just means a way to write something. Okay, a way to write, a different way to write something. Okay, and function notation is a notation where a function is named with a letter. So you use a letter, and then the input is shown in parentheses after the function name. Okay, so for example, f of x is a very common use for function notation. F is the name of the function, and then the input is x. We talked about in the last video how a lot of times your domain is called an x value because of the fact that x and y are usually used together when we're talking about a graph, and x is the input and y is the output. But let's say there was a different input. Let's say you were using a and b. Maybe it would be f of a. Okay, or maybe if you were defining two different functions, you could say f of x and g of x. Okay, so there's a lot of different uses for this. We're going to talk about it here, but for example, f of x equals 4x plus 1 is the function y equals 4x plus 1, and it's where f is the name of the function. So it kind of almost replaces the y equals part of it by naming it something different. So for example, if you had more than one function, you could say f of x equals 4x plus 1, and you could say g of x equals 2x plus 6 or something like that. And then you could really easily talk about it. You could say, well, the function f of x, if you were writing about it, has a slope of 4. And you wouldn't have to write out y equals 4x plus 1. You could just use the function f, the name f. You could also use the name g. If you wanted to talk about g, you could say g of x has a y-intercept of 6 or something like that. Okay, so those are some options to you. That's part of the reason why this is useful. And something I want to make sure that you do write down is I want you to make sure that you write down how you actually write this, or how you actually say this out loud. So if you have the f and the parenthesis x and close parenthesis, you would say this as f of x. Okay, that means the function f of an input of x. All right. So it's a lot easier. We use it because of the way that you can say just f of 3. And what this means is, you're going to talk about this in a second, is you can put different inputs in, and instead of writing out, like for example, if I wanted to evaluate, let's say I was filling in a table for this function and I wanted to evaluate it at different values, okay, at different inputs. Instead of saying evaluate, you would have to write out evaluate y equals 5x plus 6 for when x equals 2, for example. You would just say this. You would say evaluate f of 2. And then what that means is you have the function f of x equals 5x plus 6, and they want you to evaluate the function with an input of 2. So that just means you're going to take 5 times 2 plus 6, and you're going to get 16, and that would be your y, or your output for an input of 2. Okay? So for example, y equals 2x plus 4, if I was going to write that in function notation, it would look like this. F of x equals 2x plus 4. And then if it says f of 3 equals what, that just means simply I'm going to take the function, 2x plus 4, take that function, and I'm going to evaluate it with an input of 3. And all that means is 2 times 3, 6 plus 4 equals 10. F of 3 equals 10. Okay? All right, so the other reason that this is useful is because not all functions are expressed as equations. So real-world situations can be very different than just linear or some of the other functions that we're going to look at later. And so sometimes they're not expressed as equations, but then you can still call them a function. So for example, in the graph down here, this is still a function. It passes the vertical line test, but there's no one equation that we can talk about or that we can define that would create this graph. So maybe this graph is, speed over time or something like that. I don't know exactly what it would stand for, but that doesn't matter. But we can still call it a function f of x, okay? And so it's saying that, for example, on the graph below, the point at x equals 4, so this point right here, when x equals 4, has the coordinate 4, comma, f evaluated at 4. Which means that basically, if I was to evaluate this function with an input of 4, with an x of 4, then the second coordinate is called f of 4. And if we were to evaluate that, we would look for the y value, or what the output is of the function when x is 4, and that would be 1. So 4, 1. Okay? Meaning that the value of y when f is 4 is f of 4. So f of 4 equals 1. An input of 4 gives an output of 1. Okay? Input, output at function f. Okay? F of 2 is another example they use. F of 2 is 4 because if you go to when x is 2, when an input of 2 happens, then the output is 4. All right? So it says, what is the value of f of 6? Another example of this would be if you look at when input is 6, you find that point and you go over and you see that f of 6 equals 2. All right? And then the last thing that it might ask you to do is the problems might ask you to go backwards. So it says, can you find two x values for which f of x equals 1? So if f of x equals 1, so that means that the output is 1. So I want to look along my graph and find spots where the output is 1. Okay? And what I see is that for an output of 1, the input is either 4 or looks like maybe 9.5. So before class, what I want you to do is I want you to look at this function of this graph function, and I want you to go ahead and answer these questions on the right using function notation. And then I'm going to add something else, and I'm going to do an equation. Okay, so this is the graph part. You also have to be able to do it using what's called substitution. It just means substituting it into an equation. So I'm going to define a function, g of x equals 3x minus 2, okay? And I want you to evaluate the following things. A, I want you to evaluate g of 5. B, I want you to evaluate what x would equal if g of x equals, let's say, 7. And that's it. Okay, so just two extra problems here so that I can make sure that you understand function notation. Bring that with you to class the next day.